Hey everybody, and welcome back to our Master Material series. In this one, we're going to go ahead and start building out masks in order to blend both of our material layers to get different effects. The first thing, however, that I'm going to want to start doing is bringing in an asset that we can test this on. So I'm gonna grab something from Megascans here, which I've already done. Megascans gets us a series of textures. These ones come unpacked, and since we're using channel packing in our shader, I'm going to go ahead and just channel pack real quick, and we'll show you what we're going to do. Okay. So I've opened up the textures in Photoshop, and what we're going to do is a quick channel packing. There are other ways of doing this. I'm sure you can channel pack in GIMP. I would show you like how to do this in Unreal, but they're updating their tools. It's still experimental, and so once that's actually released, then maybe we can look at doing a channel packer in the actual engine itself. But for now, we're just going to do this in Photoshop. So right now I've opened up a cavity map, a roughness map, displacement map, and also a specular map. These are the only maps that came with this particular asset. And what I'm looking to do is just pack my ambient occlusion, my roughness, and my metallic values, and of course any emissive maps that we may have into one texture, and then our cavity, our thickness map if that is available, our specular map, and then our height map. So since we're missing a few, we can skip over these, but for the most part what I'm going to do is I'll start with a cavity here, and since cavity best represents AO, not completely, and this doesn't come with an AO map, we'll just roll with it. So I'm going to go ahead and grab our roughness. I'm just going to do a shift Control A to shift everything, and then a Control C to copy. And over our cavity map, under the channels tab here, I can then select the green channel, Control V, to then pack that roughness texture to the green channel. Same thing, we have metallics that go in blue, and since this does not have a metallic whatsoever, I'm just going to go ahead and paint out a black value. Make sure that's black. Since there's no metallic information on this particular asset. And I would add an alpha channel if we have emissions. We don't, so that's fine. And then I'm going to save this as, I'm just going to call this rock, so T underscore rock, ARMEM, for ambient occlusion, roughness, metallic, and emissions. And I'm going to save it to my folder, hit OK, then close this. I'm going to grab my cavity map again, and then we're going to go ahead and make our other map, which is our CTSH. I don't need the roughness map anymore. I have cavity. There isn't going to be any thickness, so in green I'm going to go ahead and paint this out black again. There's no thickness information on this asset, and if there was a thickness map I'd paste it there. And then we have our specular map. So again, we'll go to specular, Control A to select all, Control C to copy, come back over to this map we're working on here, Control V to paste it into the blue channel. So now we have our specularity map, and then we'll need our height map. So I'm going to go ahead and add a new layer. This is going to create an alpha channel for me. Go over to our displacement. We'll Control A to select everything, Control C to copy everything, come back over to this map here, and Control V to paste that in our new alpha channel. We can then select RGB and A to see all channels, and we can save this as I'm going to save a copy because I need to make this a target file to keep the alpha information. And same thing with this, I'm just going to call this T_rock. And this is a CTSH map. Cavity thickness, specularity, and height. And then we will go ahead and save that. Okay. With all of that out of the way, we're going to go ahead and bring in our Megascans assets. So I've just created a folder of Quixel asset, and you can use anything you'd like. Let me go ahead and grab the albedo, the normal, and those two PBR maps we just created and bring them in. And I'll just rename these two maps for continuity, rock underscore albedo, and also rock T_rock underscore normal. The other thing that we're going to want to do is make sure that our PBR textures here are of type mask under the compression settings. So we're going to go ahead and open them up, go to your compression settings, and select masks, no sRGB. I'm going to do that for both of these maps. Here. And save those. And those textures should now be able to be set. And all I really need to do now is just bring in our rock assets. So go ahead and bring this guy in. All right, with that imported, now that we've got this material, we won't need it. So I'm just going to go ahead and delete this. We're going to create our own material anyways. So I will right click. Let's go to our material and create a material instance. I'm going to name this mi_rock. And we can go ahead and open up that material instance, and under the parent, we're going to assign our master material. And we can close that. We can open up this asset here, and I'm going to just then assign my mi_rock. And I'm going to bring that into our scene. We just need something to test our master material on and also view how our masking is working. Let me go ahead and assign the textures real quick. So our albedo is going to be here. Our normal. Normal map. And our two PBR maps, which is going to be our AREM and CTSH. Of course, because it does not have an emissive, yeah, I believe we're getting emissions here. So let's fix that real quick. I had thought that originally we put in controls for that, but apparently not. Let's go ahead and open up our master material. So this is going to be our base material function. And under our final material here, we want to check to make sure that we are handling emissive color. So to do this, we're going to need an option. Because we have no alpha map on the texture, or because I have no alpha map on the texture I created, it's just passing a white value, and we don't want that. And we want to also be able to control whether we're using emissions anyway. So the first thing that we're going to do is we're going to add a switch. Static switch, sorry. And we're going to hook the true, which is the alpha coming out of our final AREM here into our emissive color. And for false, we're going to feed it a constant 0. So just hold one click in your graph to get a 0. And for the value, we're going to need to add an input. So I'm going to come over to my inputs here. And I'm going to do another function input. I'm going to make this function input of a static bool. I'm going to copy this static bool here and plug it into my preview. Oops. I need to preview that, and then I'm going to do a named reroute node, and we're going to call this use emissions. And I'm going to then call that named reroute for my value over here. So use emissions here. Save and plug that value in. Great. And so now we just need to go back to our master material here, as it now needs a value for that bool. So we can do something like, let's copy our enable parallax occlusion mapping, and we can rename this to enable emissions. And we go ahead and plug that in. Save that. And I noticed I forgot to name my input here. So on this input, we're just going to say in, actually enable emissions. Save that. All right, and we can close our base material function, and there, now we got our correct maps. Our emissions are occluded because we don't have any, but I also have the ability to enable them again here if I wish. All right, so with all of that said and done, let's start building out our masking function. If we come back into our material library, our material functions, and these are going to be, I'm going to make a new folder and call it utility function. And under this, we're going to create a new material function. Under materials, advanced material function. MF, call this MF underscore masking. And we can now open this up. There's a few things that we're going to want to produce so that we have some options with our material mask here. The first one being most likely a world normal blend. So that way when we're adding stuff like snow or moss or things that sit on top or beneath the asset, that we can use the asset normals to blend that in and only have that project on top or below the asset. So in order to do that, we will also need one more material function So let's go back into our folder, our utility folder here, and we're going to create one more material function. Actually, what we'll do is I'll just duplicate this one faster, and we're going to call this mf world normal blend. Let's go ahead and open that one up. Okay, to make our world normal blend, we're going to need a few things. The first input of which that we're going to need is actually the assets normal. So I'm going to do a function input. I'm going to leave this as a vector3. Let's grab just a texture to preview with, and we can pop a normal map in here. See if I've got one, just a default normal map. The other inputs that we're going to want, so I'm going to copy, copy this. This, we're going to use it as a scalar, so we're going to change it of type scalar. And we're going to need also a static bool. So I'm going to copy that. Let's make this of static bool. So this top one, I'm going to name input normal map. This scalar, I'm going to name top layer normal blend amount. And this bool, we're going to name override transform, blend transform. Okay, and from here we can take our vector3 and we're going to do a lerp. Just by clicking an L after dragging off this pin, you can create a lerp node. Let's do a constant vector3 by holding down 3 and clicking in our graph. And we're going to assign a value of 1 to the z. Let's take the XYZ information, and that's going to go into the A of our lerp. This normal map is going to go into the B. And this scalar parameter here of our normal blend is going to go into the alpha. And let's just give a preview amount for our scalar here. I'm going to hold 1 and click in the graph to get a constant, and I'm just going to give that value 0.5. So what this actually is going to do is just blend between having normal information to a flat normal, which is going to determine how much of this normal information is being masked out when we have the mask. You'll see it in action here in a bit. The next thing that we're going to want to do is we want to take this solution and we're going to transform the vector. So take out here, let's do a transform vector. Just under transform. Then we're going to want to do a switch. Static switch, sorry. Always do that. Static switch. And this is going to be in the false, and the raw value of this lerp is going to go into the true. And the bool that we have here is going to be our value. And I'm just going to do a static bool as our preview. That's false. Next, we're going to add in a few controls over here above and beyond just the normal blend. We're going to want another vector3, so I'm going to copy this one and paste it, and we will rename this to blend direction. And I also want another static bool, so we're going to copy this one, and we're going to call this one enable blend direction controls. We're also going to copy this bool here as a preview, and we'll just do a constant vector3 for a preview in this guy. Give these ones. We're going to need another switch, so we'll copy this one. Put this bool as our value. This is going to be our true. And we can do one more vector3 for the false. And we're going to just do a value of 1 in the z for the false. So what this is going to do is allow us to manipulate the blend direction that we're going to use, whether it's from the top, the sides, or the bottom, and give us a little bit more control. Usually you wouldn't use this for other things, but you could end up using it for something like rust on the bottom of the asset. It's just to give you a little bit more flexibility with the mask. Once we've got this all situated, the next part that we're going to add in for our controls is a little bit of math prior to that. Actually, we're going to want to normalize this vector so it doesn't get crazy. We want to keep it on a scale of 0 to 1. And from there, we're going to actually grab a dot product. And this switch is going to be the B of our dot product. So I can organize these a little bit better. Okay. Once we've established our blend direction, we're going to want to make sure that this is on a constant bias scale. So if you look up constant bias scale, and I found the values for me left at 1 and 5 work just fine. But this will keep everything nice and clamped. And then the last 2 bits that we're going to want to put in is we'll need another lerp. This is going to be the alpha to this lerp. And then we're going to want another constant. So I'm going to hold 1 and click in my graph here and do a -4 into our A. And then we want another scalar input, so we can copy our function input scalar here, paste that here, And this one is going to be called top layer blend max. Go ahead and keep a constant 0.5 as a preview. And once we've got that set, we're going to clamp this result just to make sure we don't get anything outside of 1 value or below the 0 value. So we'll do a clamp. And the last thing that we're going to do is then multiply all of this by another scalar input. So I'll copy that one, and this is going to be called top layer opacity. Basically the strength of this effect. And we can go ahead and keep our 0.5. And then we can plug that into our result. Now, as far as the naming of these goes, it's up to you. I've used top layer because I generally use this solution to mask in a top layer such as snow or moss. But if it makes more sense to you, you could just name it something like world normal blend amount, normal blend max, normal blend opacity, etc. So with this function done, let's go ahead and save this. And we're going to bring that into our MF masking function. And we'll drag off of this and do a named reroute. And I'm just going to name this WMB for world normal blend. We're going to also need a few inputs for this mask to work as well for its intended use. So the first thing I want as an input in this function, do a function input, is a material reference. So we can change this to input material attribute. Off of this material attributes, we can then get material attribute. And the material attributes that we're going to want access to is going to be, first off, the normal. And the second thing being our ambient occlusion. Find our ambient occlusion. Then off of these, we can do a few named reroutes. So I'll just do named reroute. It's going to be our baked normal. And this named reroute is going to be our ambient occlusion. Okay, and then I'm debating whether we want to put the controls in this function or expose them to the master blueprint. I'm thinking exposing them to the master blueprint would be more modular if you wanted to reuse this masking solution for, say, a third material. So I'll probably do that as opposed to just putting the actual controls into this material function here. So I'm going to comment this and just say this is our material inputs. far as the preview goes, I think you can just do another get material attributes. Plug that in just to stop it from complaining. We'll see. Okay, with that set up, let's go ahead and set up our world normal blend inputs. So off of here, I just want to make sure that these are all set up logically, which is probably going to be fine. So I'll drag off of here and I'm just going to type function input. Again, this is layer blend, a layer normal blend. Drag off of this guy, do another function input. Name this one override blend transform. Same with our direction. Blend direction. And enable blend direction. Oops, I'm going to now put function input. This is blend max. And this one is going to be our blend opacity. And for our normal, we're going to grab our named reroute baked normal and we'll plug that into our normal map. This up a little bit. And for our previews, let's just do a constant one. For our scalars. Our constant 3 vector for our direction. Actually, I suppose we could just keep a scalar for now. And a static bool. Fall. Real quickly, I want to say something. Throughout this actual series, I do make a mistake in my function inputs by making it just a regular bool. You want to make sure that the property of your function inputs are set to static bool. I realized this much later after it's caused me problems and then I go back and fix it, but I would rather you just have that in mind right now and make those corrections as you go throughout the series rather than have to fix it at the end. It's kind of annoying. So just to save you time, there you go. For our bools. I'm going to comment this and just call this world normal blend. Masking. And we're going to save that. And next we're going to look at pre-computing normals. This offers a little bit of a different solution to the masking. So to pre-compute, I'm going to start by grabbing our bake to normal, and we're going to do a compute filter width. Hey, me again. Don't do that. Leave the compute filter width out. It was something that worked in UE4, but does not work with this solution in UE5. We're going to then mask, do a component mask, and we just want to grab our R channel, run this through a power, and then we'll want another function input. So off of here I can do function input, and we're going to call this one grunge cavity. Actually, I should say mask cavity power. When I built this, I originally used it for a grunge map, but you can use the same thing. Just give this a constant 0. Off of the power, we're then going to multiply by dragging out and hitting M. We're going to need another scalar parameter, so I'm just going to copy this one, and we will go call this a mask cavity strength. So another interjection on these two function inputs here, I would just leave out the actual tag cavity and just use mask power and mask strength. It's more conducive to what we're using this for. This was previously used for something else, but it makes more sense in this case just to define it as your mask power and your mask strength. Up to our 0 there too. After this, I'm going to then do an add. It's going to be our B, and I'm going to do a constant for my A of 0.1. And then I'm going to multiply this solution by our world normal blend. So if we grab our WNB here, our named reroute for our world normal blend, and plug that into the B of the multiply. And then from here, I'm going to do a static switch. We'll leave this as the true. As far as the false goes, for false, we're just going to hook up our 0.1 constant. And off of this, we're going to get another function input, the true. As far as the false goes, for false, we're just going to hook up our 0.1 constant. And off of this, we're going to get another function input.
So right here, I didn't catch this, but when you actually drag off of the value pin in the static switch and look to make it a function input, it actually assigns a default value of bool to that input. This is where I make the mistake. You want to make sure that these are actually changed to static bool as the input type, not bool.
And then we can go ahead and add ourselves a named reroute node for this solution. And I'm just going to name this PCN for pre-computed normal. And then comment this whole thing and say pre-compute normals. So after that's done, we can then work on using some of our AO as a mask as well, just as a feature. So if I grabbed my ambient occlusion reroute node, we can then multiply that by a constant of 1.05. And then we can take the solution as the alpha of a lerp. So I'm just going to grab myself a lerp, plug that in as our alpha. Going to do a scalar input, so let's copy this one up here. We'll rename this to AO influence. And that's going to go into our A. And we're going to use a constant 0 for our B. That over. We can then look at blending in our pre-computed normals. So we'll drag off of this and we'll hit A to add. This is going to be the B of our add node. And for the A, we're going to grab our PCN, our pre-computed normals, reroute. And then we're also going to use a static switch. And that will be our true. If we're using false, we're just going to go ahead and plug the pre-computed normals directly into the false. Off of this value, we're then going to do another function input. And then we're going to call this input enable AO masking. Go ahead and grab ourselves another static bool as a preview and plug that in. The second part of this, we're going to drag this down here. We're going to do another add. And that's going to be the A, and this time our pre-computed normals are going to be in our B of the add. And we're going to want a lerp node. This is going to go into our B. And we're going to want our, let's see here. I'll help myself. Don't worry about this alpha here of this lerp just yet. We'll go ahead and finish up this logic, and we'll come back to that in a moment. But from the switch up here, what we want to do is another lerp. We'll leave that as the A. We'll take off the B. We're going to want another function input. And on this scalar, we're going to call this input say texture mask amount. And we can use another constant 0 just as a preview. This is going to be our alpha, sorry. And this lerp down here is going to go into our B. And then from here, we can then do one more static switch. And for the false, we're just going to bypass this altogether from our previous switch. And for this value, we're going to do another function input. And we can call this one enable texture masking. You can also plug the false in for the preview on that. Great. And then we'll finish this section off by doing a named reroute. And we're just going to call this AOM for ambient occlusion mask. And comment this. And I'm going to comment, say, mix ambient occlusion masking. All right, as previously stated, for this alpha, we need to solve for that. So what we want to do is we want to have the ability to also use a texture as our mask. So for that, I'm going to first do a, let's do a function input here. And we're going to want this of type texture 2D. We can then, let's get a texture 2D as a preview. Texture object. Okay, and off of this texture 2D, we have a couple of things that we can do. First then, let's do a world alignment. So do world aligned texture. And then we'll also drag off of this and just do a regular texture by hitting T. For texture size, we will drag off of this and do another function input. I'm going to call this texture mask tiling. And we can do just a preview of one. Then off of this, we're going to then, since it's world space, we're going to multiply this by 500. Put that into there. And then to solve for the UV, we're going to take this, we're going to do a component mask, single out just our R channel, and then we can then multiply this by a texture coordinate node. And that's going to go into our UVs here. From here, we then want to determine whether we're using either the world aligned texture or regular UV. So I will drag off of the XYZ texture, and we'll use a switch, static switch. And I'll use my RGB as the false, the static switch, and then off of the value, we're going to go ahead and do another function input and name this one use WA, our world alignment, for texture masking. Go ahead and grab another static bool for our preview and plug that in. Then off of our switch, we're going to do a multiply and follow the multiply up with a cheap contrast. And finally, we'll do a named reroute, and we're going to call this TM, or texture mask. Let's realign these by selecting them and hitting Q. And off of these, we're going to want 2 more function inputs. So let's do that. This one's going to be a scalar, and we're going to call this texture mask intensity. And this next one, we can just copy this, and we're going to call this texture mask contrast. In there. And I'm just going to use a constant of 1 for the previews in these. And save that. Then we'll comment this solution and call this texture masking. And now we can use this TM reroute as our alpha up here in our ambient occlusion mask. Don't worry, we're almost done. I'm gonna keep this in order. Actually, this is gonna come next. This will be the final. All right, and the last type of masking that we may want to include is mesh paint masking. So in order to do mesh paint masking or vertex color, it's going to be up to you. I can probably include the option for both. Mesh paint is going to be Unreal's new way of replacing vertex color, but vertex color can still apply in some cases, so it may be nice to keep it as a solution. But if you're using Nanite, typically you're going to want to use the mesh paint. So let's go ahead and set that up. First thing we're going to do for that is we're going to grab ourselves a vertex color node. And the next thing that we want is a texture sample. So just hold T and click in here. The important thing about this texture sample is we just want to drag off of the texture, and we're going to look for a node that's called mesh paint texture object and assign that. After we've got these solutions, we can then drag off of the RGBA data, and we're going to put this through a switch, static switch. Depending on how you want to set this up, I may want mesh paint. Yeah, no, let's use vertex color. We'll use mesh paint as a default. So I'll plug the RGBA of the mesh paint into the false, and then the RGBA of the vertex color into true. And then we will drag off of our value and do a function input. And we're going to call this one use vertex color masking. In the description, I'm just going to make myself a note. Default is mesh paint masking. Let's go ahead and grab ourselves another bool. Let's use a false bool and plug that into our preview. And from here, we can do a names reroute node. And call this paint mask. Now, all we really need to do is let's see here. Might want a height map. So let me think here. Let's so the material make normal. Yeah, we may want. Let's grab a displacement and do a named reroute for that. Let's do a function input. And this is going to be of scalar. And we're going to call this height map. Drag off this, do a switch. Static switch. We're then going to grab our displacement and plug that into our false, and then off of here do one more function input. And we'll call this input use alternate height map. Do a constant 0 and grab myself another bool for previews. And we'll also drag off of this. We're going to then do a multiply. Off of this multiply, another function input. This one we're going to call height map influence. And a cheap contrast after this. Copy this function input and rename this to height map contrast. That will go into our contrast scalar. And then we can just do a constant 1 for the previews on these. Next, when we've got our, since we're multiplying this, we may want to get a little bit of the information back. So what I'd like to do is just do a divide. So if I drag this out and hit D, you can divide. I'm going to divide by 9. We're then going to do a lerp. Lerp is going to go into the alpha. And then we're going to grab our AOM, or ambient occlusion mask. This is going to go into the A. And our B we can leave as a constant 1. Then off of the contrast, we can then do this as the alpha of another lerp down here. And we'll grab our AOM once again and plug this into the B and leave A as 0. And what we're going to then want to do is compare these. So if I drag off of my height map influence here, we're going to do an if statement. Okay, so as that parameter as the A, we want a B, which I'm going to do a constant of of 9 to my B. Then this bottom lerp we're going to use as both A equals B as well as A is greater than B. And for this A is less than B, we're going to use the top lerp. Let's clean this guy up a little bit. All right, and then we need to incorporate our paint masking. So we will drag off of this, and we're going to do one more lerp. It's going to be in our B. And because this needs to stay modular, let's drag off of this and just do a function input. And this input we're going to call paint mask channel. We can grab our paint mask as a preview. But the idea behind this is we're going to grab this paint mask as an output, put it through a channel mask parameter outside of the function, and then we'll feed that back into the function as this alpha. That'll allow us a little bit more flexibility and control over which actual channel we want to use for our mesh paint or vertex paint, while allowing us to use more than one of these functions within the material itself. So we leave the A as 0. We're going to do another switch here. Let's do a static switch. And we can drag off of this one and do a function input. And name this to enable mesh paint. Let's grab a regular static bool, plug that into the false right now. Make a note in the description. This option also enables vertex painting alternatively. Okay, and once we've got that, this will go into our false. From our if statement. We then have a lerp, and from this lerp, this is going to go into our B. Our alpha mask is then going to also be our ambient occlusion mask here. And then from there, we do one more switch so we can copy all of this. And rename this Boolean function input to enable texture masking. Enable texture. So if I already have that one, let's call it solution. Enable texture mask solution, where this is going to go into our true, and then the false will be of our previous switch. So giving ourselves a little bit of flexibility with features here. And then before we send this out, we want to go ahead and do a saturate. just to make absolute sure that we don't have any wacky values. Okay. Now, it says we can't cast static pool. Where do we have that issue?
So this was the point in which I realized that the inputs were actually incorrect and it was set to a bool, not a static bool. And so this is why I'd given so many prior warnings as I was going through this. If you did change all of your inputs to static bool as the type instead of bool, then you shouldn't be seeing this warning. If you are getting this warning, just double check all of your function inputs that are of type bool and make sure that they are set as static bool.
Okay, I found the issues. These inputs actually that are going into the static switch need to be of type static bool. That's my bad, so I'm just going to go through and make sure that all of them that say bool say static bool. Which I believe is on every single one of my switches, yeah. So don't be like me, use the correct input type. I believe I've gotten all of them now. Okay. So with those errors cleared up, now what we can do, let's go ahead and comment this part to say paint mask. Oops. Paint masking. And then we can comment this whole section and say this is combine masks and output final result. And we go ahead and save that. Last little bit I want to do is I want to make sure that these texture samplers are shared wrap. This one's going to be a shared clamp for the mesh paint texture, because that doesn't wrap. And I think we're good on that. So we can save that, and we just want to look at our outputs now and make sure that they are all in order. So the first thing I would imagine that I'd want is my material input. Then we can go down our world normal blending here. So let's see here. First thing is the Boolean options. So I'm going to say enable blend direction is 1, override transform is 2, the opacity is 3, blend max 4, normal blend 5, and direction 6. Then our world normal blend static bool I'll also leave as a 1. Recompute normals, let's do 7 and 8. Texture masking solution will be 9. Back over to texture masking. I forgot to name this input. This is our texture mask as our 2D vector, and this will be 10. Then our tiling will be 11. We'll also put world alignment as a 9. Intensity is 12. Contrast is 13. Next step down is the ambient occlusion masking. So we'll do that as 14 for the enable, 15 as the influence, do 9 as enable texture masking there, and 10 as the texture masking amount for the ambient occlusion. And then we come to our height map here. Let's do height map as 15. Alternate is 16. Influence 17. And contrast is 18. Then for our channel mask, let's put 20 as the enable mesh paint and 21 as the channel mask, and also 20 for vertex color masking. Now, one more thing we need to do is this actually we need as an output. So I'm going to say function output, and this result I'm going to name to paint mask. And we can save that. Okay, with our masking all done, we can now come back to our master material library, and then we can go to our utility functions and pull in this masking function here. Essentially what this does is this is going to be our alpha to blend between this base material and a second base material to output a final result. Alright, so let's go ahead and start hooking up our inputs for our mask here. We're going to need the material, so we can drag off of our set material attributes here and do a named reroute node. ET. Let's say base material detail normal, BMDT, good enough for me. Let's grab that and put that as our material in. And we're going to go ahead and set up our bools now. So we need a static bool parameter. And name all of these real quickly. One thing of note real quickly here, so you want to, for your alternative height map, you'll want to actually create a texture sampler, and then we'll feed the red channel from that height map in. And then finally, we've got our paint mask here. So what we want to do is we'll drag this paint mask out, and we're going to look for a channel mask parameter. And we're going to call this our paint mask channel. And then the solution of that will go into our channel there. Let's try to clean this up as best we can. From here, actually, probably do a named reroute. I'm just gonna call this paint mask. And from our results, we'll do a named reroute. I call this material mask alpha. And down here we can use our named reroute paint mask. Comment this and just say material masking. And then it's just a matter of organizing our inputs into categories. So what I'll most likely do for this is we're going to put this into we can do this in our material settings. However, we're going to add on a category here. So I'm going to do a bar and call this material masking, and probably another bar, and this is going to be world normal blend. I'll put all of my world normal blends into that category, or that group, sorry. Next one we got is going to be our texture masking. So I'll rename this texture. To make sure that we get all of our texture stuff in that category. Let's not forget the texture itself. Next one, copy this and change the ending to ambient occlusion. Cavity strength and power is going to go into that. As well as our AO influence. And the next category is going to be our height map. Make sure to set this sampler to shared wrap. All of our height map stuff in here. And the last little bit is going to be, of course, the mesh painting. So that's to mesh paint. Again, and description, I'm just going to say for this category, handles both mesh paint and vertex paint controls. Vertex masking in there, and our channel in there. I believe that should be everything. It's under AO, under our material masking, Mesh paint. Texture masking. World normal blend. And finally, our texture variations. So we also want to make sure that we have these organized so we can look into our AO first. So in our enable ambient occlusion, let's set this to the priority of 0. AO influence, power, and strength can stay the same. That looks good. Let's look at our alternate height map. So put alternate height map at 0. That looks good. Let's take a look at our mesh paint. Put vertex color put this at 0, and then we can actually just, yeah, so paint mask channel's fine. Should be named okay. Enable mesh paint should be 0. Vertex color masking should be 1. That makes more logical sense. And then enable texture masking is fine. World align, the texture mask, amount, contrast, intensity, and tiling. And then for our world normal blend, enable world normal blend, we'll put at the top. So that's going to be 0. And we'll do blend opacity. It's 1. Mount 2. Max is 3. New blend direction, world direction, and override blend transform is all fine there. Use texture variation is all set up, so that should be good. Now we just need some default values. Opacity should be 1 so that we can see it. Blend max, we're going to put it 1. Let's put some controls on our opacity so it only goes from 0 to 1. Blend max only goes from 0 to 1. Blend amount also 0 to 1 at a 1. Make sure I check my max. Blend. Okay, so blend max is just a B. I think we can go a little bit higher with that. Opacity 0 to 1. For blend max, we can put it at 2. Amount 0 to 1. Direction default value is going to just be 1 on the Z. Mask texture, this needs to be a default mask. Default masks texture. Gravity power can be left at 0, strength can be left at 0. Texture mask amount, we'll just put it 1. Texture mask tiling, we'll just have it 1 as default on the RGBA. Height map will need a default height map. So if I just type in height, and we can put any sort of height map in there as default. I'll scrap one from the engine. Intensity, we're going to leave as a 1, contrast at 0, AO influence at 0.5 as a default. I believe it goes 0 to 1. Height map influence is 0 to 1. And we'll leave that at 0.5, and height map contrast is fine at 0. Default channel for this is red. And we should be good on our material masking. So to blend the two, what we're going to do is we're going to copy both our base material as well as detail normal, control copy and control paste them. And so this doesn't control this. We do unfortunately need to rename these to something that is going to be usable for our second texture. So I'm going to start with this. This is going to be secondary material. And I'll rename this to SMDT, secondary material normal detail. And we'll need to set up categories for these as well. So
one slight mistake I made here. Make sure that you have renamed all of your parameters and bools and everything before setting up their categories. If you try to create a new category while it still shares the same name with the node you copied it from, what's going to happen is it's just going to put both that node and then your previous node from your base material into a brand new category and erase the previous one. So take the time to go ahead and just rename all of your variables, or parameters, I should say. And once they're all named to, say, secondary, then we can go ahead and assign those actual material groups.
we can move the material settings for these to most likely number 4. It's going to be material settings. Or in the secondary material settings. Since this is number 1, this is going to be a number 5 secondary albedo. This will be a number 6 secondary normal. Be a number 7, which is secondary PBR. And this is secondary material mask. And this is going to be in our secondary material settings of number 4. This is going to be in our number 7 secondary PBR settings. And this is going to be our secondary material mask. This is S mat mask. This is also going to go in secondary number 4. And what we'll need to do is, of course, duplicate our functions here with secondary labels. That way, none of these controls that we're using for our primary material affect our secondary material once we've gone through and updated these categories. So this is PBR, so we can put this in our secondary PBR. Parallax occlusion mapping secondary material. This is going to be our secondary. And we just want to go through and rename all of these. So we'll do that now and be right back. Okay, so with all of those renamed and categories changed, the next thing that we need to do is get ourselves some of these controls here. So if we now locate to our albedo functions, and we want to have the albedo settings, we're going to go ahead and duplicate that for our secondary material. So let's go ahead and duplicate. And I'm going to say else albedo settings M2 for material 2. Can open that up. And here, you just need to rename these. And of course, we need to put these all in the correct category. So I believe this was number 4. Let me check real quick here. Number 5, okay. So yeah, these will all be number 5. Secondary albedo settings. Yeah, secondary albedo settings. So we can save that. Close it. Close our world normal blend here. And then we can replace our albedo settings here with our secondary ones. Then we need to update our normal settings. Let's go to our normal functions. Look for normal settings. We'll duplicate. Call this normal settings underscore M2. And open that up. And we'll rename these to secondary normal. And we'll check the category real quick. It's number 6, secondary normal. So we can grab all of these. Number 6, secondary normal. And the material settings is going to be number 4. Material settings. And we can save this. Let's bring this into our master. And replace these two. Save that, and then we can duplicate this for our detail normal here and just move these pins over. Next, we will tackle our parallax occlusion mapping settings. Just here, so we can, this actually is in our UV. That's okay, we can keep it here. We'll duplicate this. This palm settings M2. Open that up. Okay, so I need to relocate fuzzy shading and parallax occlusion mapping. So fuzzy shading makes a little bit more sense to be by the albedo settings, since that's what it affects most. Parallax occlusion mapping we can also put with the PBR settings. So there's a few changes that we'll need to make very quickly. Let's open up our material function fuzzy shading. And for fuzzy shading, let's change this to 1 as the group. And then for our parallax occlusion mapping, let's change this to 3. Yeah, 3 PBR settings. Actually, I noticed here, it says 1 fuzzy shading. This should be 1 cloth shading. So in your cloth settings, just change the group to number 1 cloth shading. In the fuzzy shading, change the group to 1 fuzzy shading. In our parallax occlusion mapping settings, we'll open that up. And all of these should be set to 3 parallax occlusion mapping. So that will keep them together with their groups respectively. We can close all of these original settings, and then we'll turn our attention to our Palm 2 settings. So instead of it's going to be secondary parallax occlusion mapping settings, and this is going to be in our number 7. Change that to 7 and save that, and we can close it. Then we can look at our fuzzy shading settings. Let's duplicate this underscore M2, open that up, and this is now going to be secondary if I can spell it right, secondary fuzzy shading, and this is going to be in the group 5. Do group of 5. Save that. And the last one is going to be the cloth settings. So we're going to duplicate this one. Underscore M2 for the new naming. Open that up. And this is also going to be in the group of 5. and put secondary. And we can save that and close that. Okay, and the final function that we're going to want to duplicate for our second material is our material settings material. So if we right click, we will duplicate this. Let's call this material settings M2. And in here, we also want to relabel all of our settings here. So this is going to be secondary texture tiling, secondary borderline projection contrast, and secondary texture rotation. Let's save those. And then we also need to assign their group here. So again, at my master material, and secondary material settings is going to be this group. So I'm going to copy the number 4 secondary material settings, and then we can come in here and Control V to paste that into our new function. All right, so we can close that, and then we're going to drag that new function in and replace our MF material settings on our secondary material. Let's name this to secondary material. Material settings M2. And we'll just control click and move these pins over. So now all we do is just replace those functions inside of our master material here. So I'm going to drag in my cloth M2, my fuzzy shading M2, and my parallax occlusion mapping M2. And we can swap those out. So let me save this real quick in case we crash. Let's hook up these. Don't need that any longer. Let's look at our replacing our fuzzy shading settings and our cloth settings. This is why we made functions out of these settings, is so that it makes it fairly quick and painless to swap out new ones for secondary and tertiary materials without having to do a whole crud ton of work. The last one, and I think we have a POM settings here that we have to replace as well, so we can copy this over here to our detail normal and replace these as well. Save that. And the last ones that we have to tackle is our PBR settings, so let's go ahead and do that now. Let's go to our PBR functions. Go to our MF PBR settings. We'll duplicate this and rename it with underscore M2 at the end. Open this up. And then we just need to add secondary to the beginnings of these. And then we just need to put them into the correct category. So this is going to be secondary, and the category number is going to be, PBR was 3, it's going to be 7. we can go ahead and change this 3 to a 7. Save that and close that now. And we can now drag this into our master material and hook it up, replacing this guy. And once we have our secondary material in, all we really need to do now is blend between the two. So we've got a material here, and we've also got the material here. So we're just going to do a blend material attributes. Our material mask alpha is going to be the alpha. The A is going to be our base material detail tile, and our B is going to be our secondary SM DT. We can do a named reroute here and call it blended result. Can name this with a comment, blend materials. And then from there, we can get our blended result. And plug that in to our output. Now, there's one more thing, is that you may not need a secondary material, and you may just be using this just for one asset, in which you wouldn't really need this. And so in order to fix that, the only thing that we would do on the blended materials here is we would just put another switch for condition. So from here we'd do a static switch. We'd also then get a bool, static bool parameter, and we'll call this enable secondary material. We're going to put this in our material settings category. And for the false, we're just going to hook up our base material output. And then we'll plug that into our blend result. Compile and save that. We can close these now, and then 1 second, I'm going to grab some Megascans Moss texture, and then I'll show you how this all works. Okay, and I'm back. So now I've got myself some Moss texture for our asset here. I'm going to open up the material instance. Okay, so the issue actually stems from the compute filter width. So we just need to put an additional check on. Okay, a few issues we're going to clear up. Things have changed between, obviously, UE4 and UE5. So the compute filter width is causing some abnormalities. So we're going to make one change. If we go into our master material, go into your masking, and this is where we're going to make the change. Into the R, just like it's shown here, and we're going to move that switch right over here. And so as I stated in the video, I completely got rid of the compute filter width, and instead what we're going to do is change up this section at the end. So there used to be a multiply here. You can delete the multiply and just have it do this. Go from your add back into the false, copy your world normal blend, or at least get your world normal blend named reroute and plug that into the true. And then this enable world normal blend static bool will go into the value for your switch, and then that will output to your PCN named reroute. If we look at our go back into our master material, if we look at our normal function, so our normal settings, make sure in normal settings that normal flatten, usually the secondary, is set to 0. If it's set to 1, you're going to get no normals because it's flattening them basically to 0, which will affect the blending. So make sure that that is the case for your MF normal settings M2, as well as your MF normal settings 1. If you come in here, also make sure that this is set to 0 as default on normal flatten. With all of that done, you should now be able to correctly see the world normal blend. So we can change the opacity, we can change the blend amount, and we can change the blend max. Put a higher value if you really want to, and it will pretty much stay on top of the normals. This is with the 3 or 4. So you can see it conforms there with my moss texture. And we can also change the direction if we enable our blend direction. So a -1 would be from the bottom. 1 is going to be on your Y, or your G is your axis, the opposite side. So this is just helpful if you need to do some sort of art direction for which way this is actually blending. And if we don't want normal world blend, we can turn that off. It seems that that filter width is still causing issues. Yeah, this is causing some major issues now in UE5, so for now I'm just going to go ahead and delete that. It's causing too many problems. If you have a height map, you can also use the height map masking. This one does not currently, but it would use the height map from your CTSH, the alpha. Of course, ambient collusion, if you have an ambient collusion map, which this asset does not, but this would mask out the occluded areas. And of course, mesh paint. So in order to use mesh paint, if you enable mesh paint on this, we can select the red channel, and in order to mesh, you would need to then go to your mesh paint, go to texture color and add, and this will assign a virtual texture here, virtual mesh paint texture to this asset that you can then come back and paint in or out. Make sure I'm only on the red channel. Let's make sure that our mesh paint is not being occluded. Something else for the B. Using mesh paint.
So here basically what I did is I just removed the B input from our lerp that was using the mesh paint and put a constant 1 in place of the B and left A is 0. So you can do that too. It'll give a mesh paint solution. If you wanted to just paint out all of the other masks, then you could leave it as is. It's really going to be your choice, or you could even add an additional switch with an additional function input if you wanted to switch between solid mesh paint or painting out the masks. The choice is yours, really.
Yeah. So we'll want to change that to 1 in the lerp if you're using mesh paint. Again, I apologize for some of the issues. This has been kind of adapted from UE4 when I did all of this, so things have changed, but yeah, you can still paint in a lot of this. And there we go. So with masking done, we come one more step closer to completing our master material. And please feel free to mess around with this. If you have any questions, leave them in the comments below. And we'll see you guys next time. Take care.